Alright guys, by this time you may be quite annoyed with the fact that I keep lying to you about what the next video is going to be, etc, etc. But I realized that there's something I missed in the whole explanation of how Unreal worked and a bunch of other things. And probably you're going to be hitting this particular problem right about now. In other words, as you're polishing. So you should probably watch this while you're polishing, or if you hit a wall and you're polishing, I don't know. Hopefully you're watching this before you solve your problem, because most likely you will have a problem like this at some point in your development cycle of the game. And that is the fact that the physics engine in Unreal is kind of, well, it's kind of interesting, to say the least. Now, first of all, if you're using a character, right, a character actor, that means that the physics in that character actor are actually not part of the real physics. He can interact with the actual physics engine, but he's not actually moved by the physics engine. Okay, that's one thing. So barring that, I'm not going to talk about the character actor at all and how it interacts with the physics engine, because that's a huge class, and they have like a lot of shit in it. All right, there's loads of stuff for swimming, double jumps, regular jumps, like all sorts of stuff. There are of course certain limitations with it. That's the reason I decided to use the pawn. Now presumably at some point you may have used the pawn yourself, and if this pawn has collision on it, it is very likely that it will interact with physics objects. So what is the physics engine really in Unreal? Well, for starters, unfortunately at this time, 4.18, as far as I am aware, the physics engine is running on the CPU still, meaning that I think it's physics 2.2. I don't know. Don't quote me on that. You can Google it yourself. Plus, whatever I tell you now is not going to be relevant by the time you watch this. So Google it out on your own, figure it out on your own. But as of this moment, the physics is running on the CPU, meaning that it's significantly gimped. The accuracy of calculations are gimped, and I am not sure. I'm pretty sure even on the packaged games, it still runs on the CPU. You might have to download either like some extra plugin or have your own code, or I think there's an NVIDIA branch with it. I'm not sure. I can't tell you exactly. You have to do the research yourself. So if you're doing really heavy physics-based game with orbital mechanics and aerodynamics and fluid simulation and a bunch of other physics-based stuff, you might want to actually get the NVIDIA version of Unreal Engine 4, because it has all that technology woven into the engine. Now, of course, that means you need to have an NVIDIA graphics card, which Unreal Engine does not actually require, meaning that this is obviously done for compatibility's sake, not for anything else. And that's why it's running, I think it's running an older version of physics, because that can actually run on the CPU, either an older version of physics or it's just gimped by default so that it can sort of run. I'm not sure if it's possible to package the game for NVIDIA specifically. I haven't found such a method this particular engine version. Maybe in the future again it will work. But you have to understand that the graphic cards have a lot more precise floating point calculations, and they can actually do them faster than the CPU, because the CPU is loaded with a bunch of other shit that has to be dealt with as well. Whereas graphics cards are just dedicated to that, to basically that, right? They just run calculations all the time. That's why people use them for crypto mining and all that jazz. So you have to understand that the physics are not perfect in the engine. That's number one. Second of all, it's being calculated. By the way, the reason also for that is because it's on the CPU, is because NVIDIA is not going to make drivers for ATI cards to be able to run physics, right? So if you have an ATI card and you want to develop a game, tough shit. That's another reason, by the way, why, as far as I'm aware anyway, why the physics runs on the CPU. Now, that aside, let's continue where I left off previously. So we have two objects here, okay? As you can see, I have a worm, which is the player controlled object, and I have a ball, which is a physically simulated object. If I go onto my actors and I just unhook my hit logic here so that you can see what I'm talking about, if I play this right now, you'll see the same behavior as before. So as you can see, my ball flies off into the atmosphere, and I've given it quite a lot of force, and it's just very, very easy to launch it into space, so to speak. So you might think to yourself, okay, if you run into the same problem where you have an object that has collision, but obviously does not simulate physics because the worm is, of course, implementing floating pawn movement, and floating pawn movement does not actually implement physics. So, you know, it's you got to figure out what you want. Therefore, you still have collision, however, so interacting with the physics objects creates a certain amount of challenge because you need to define rules. How is that going to happen? The reason you can't just change the the physics on the ball. If I actually edit the blueprint itself, the reason you can't just change the physics of the ball currently, as you can see, it's only 2 kilograms in mass. Now, I don't know, I don't know, I haven't played around with the numbers yet, but you've got 2 kilograms of mass. You think, all right, what if I disable this and I go to my mass scale, which is kind of like the floatability of how floaty your object is. So think of it this way. It could not be very massive, but it could be but have a large mass scale. You could have something like that, but generally mass scale automatically calculates the mass in kilograms. I'm not sure what's the formula behind that. I haven't played around with the code. Don't really care, frankly. But you could say, okay, I want my mass scale to be 666, and as you pump that in, you will see that my ball right now weighs roughly 73 tons, which should, in all fairness, by the way, always save before you compile. Don't follow me. This is a vice of mine. I can't stop. If I play this right now, you might think that, all right, well, that's 73 tons. There's no way that thing gets launched. But it gets launched just as easily as the rest. So the mass scale doesn't really matter. Now, you could go ahead and apply your own gravity, which would be, of course, a downward force of negative, a force of negative 9.80665. And that would add extra gravity onto the ball. And it would be heavier, per se, because you're adding artificial acceleration, or you're just multiplying the gravity by 2. Okay, so that's what you'd be doing, and it probably would work. You also have other options. Like I've said in a previous video, you could use the linear damping here, maybe from 0.1. You want to go to 0.5, right? And you will still have some kind of an effect, but it's not going to be dramatic. And it's at some point your ball is going to stop, especially if you have a high enough damping. So that's something that you also don't want. So you should leave it at 0.1 as it is right now. Okay, so as you've noticed so far, nothing I do has a significant result in the physics here. Even if I decided to play around with the inertia tensor, this just means how hard an object is to stop on each axis. So you probably won't have to edit this, but you could if you really wanted to. And there's a bunch of other things, like I have no idea what mass deep penetration is. So I suppose I have no idea what that is, right? You should go to the docs and figure it out, because there's a lot of stuff here that is very well explained and documented in the documentation. But the basic gist of it is, yeah, you got mass, you simulate the physics, enable disable gravity, you got some constraints. There's some angular and linear dampening to simulate air resistance. You got the mass scale, which automatically calculates your kilograms, or you could just input them manually, like I did before. And you've got some sleeve families. The way this works. You could have a sensitive or custom, so basically how fast your physics are running. And then, of course, you got some settings here, such as what's the sleep threshold and how many iterations the solver is going to have. I think 16 is the max. No, it's not. Okay, that's going to be... Wow, I didn't know this was... Yeah, but the substepping is 16. I'm pretty sure on that. I don't think it's here, though. I think it's somewhere else. I think you need to define a custom. Anyway, the point is that no matter what I do to this object right now, I'm not going to generate the gameplay that I desire. So this is where you had a problem. This is obviously the point of this video. How are you going to interact with an object that is kinematic? Okay, this is a kinematic object because I'm driving it. I'm basically telling it where to go. I'm directly changing the position of this object. And a simulated physics body, which means that every interaction with another object needs to have, in order to be properly simulated and calculated, needs to have physical properties such as mass and the amount of force that will be thrown around these objects. Okay, because again, whenever you have two objects interacting, the Newton's third law is going to apply, and also obviously the more massive object is going to have a huge advantage over the less massive object. I'm not sure if density is calculated actually in Unreal Engine 4. I think you might have to implement this yourself. So if you have a balloon that is extremely dense, you could simulate this, fake it, okay? And that's, by the way, what I'm going to talk about here. One of the ways you could solve issues in general, not just with physics. I'm going to use this as an example. But one of the methods you can use is to cheat. I'm going to show you a really simple way I've sorted this out. So I'm going to hook this guy up and show you what the effect is. Assuming, of course, my ball is not 78 tons in weight. So I'm just going to enable my cat mass back in kilograms, so it's 2. Now, it's still not enough. What the hell? Is it because my mass scale is just redonkulously high? Oh, it's still 666, yes. Okay, let's just put it at 1 then, I suppose. Let's see if it's going to have an effect. It's still kind of crap. Let's lower it down to 0.1, I suppose. Maybe something like this. I just want to have it a little bit playable. Yeah, there's definitely something. Is my dampening still on? I'm not sure what I've changed now because I got a bunch of crap happening. 001, that's what I want. Okay, let's see now. Yeah, there's still not enough. There's still not enough impulse here. But we'll talk about that in a second. I just wanted to show you that I managed to change the way the ball behaves based on the hit event. Now, that's not the only way of doing this, of course. And this is where I'm going to be segueing into how you generally solve problems in Unreal, or anywhere, really. You either do it the correct way, right? So whenever you're making a framework, whenever you're doing something that will be scalable, you need to have the most efficient, the most reusable, and the most unbreakable code that you can think of. Okay, anything that is a framework needs to be rock solid, because anytime you have something that's broken, the more you build up on it, even if you fix it somewhere along the middle of the line, it's still fundamentally broken. And then if you decide to fix the fundamental bit, then your future fixes are going to fail, and you're going to break something at some point. So you want to have, whenever you have a framework happening, you don't want to be skipping on the efficiency or the actual sort of beauty of the script. But in this case, you could also cheat. This is what I'm doing. I'm kind of cheating, and another way would be to brute force it. If I were to use a wall as an example, so if you're walking and you run into a wall, so to do it correctly, properly, let's say you want to build a house on the other side of the wall. So what you would do is basically run around the wall and go behind the wall and build your house. That would be the correct way, the proper approach. And that would be a rock solid approach. And it would be very scalable, very reusable, etc., etc. But sometimes the effort required to actually do that, or at least program it in such a way that it will be reusable and scalable and all that, doesn't justify the ends, okay? In my case, I only have a very simple setup, and I only need the ball to behave the way I want it to. Therefore, the real scalable thing is kind of unneeded, right? An example of a scalable would be, look at my worm base, right? I could create as many worms as I want, but they're not going to work. That's because my controls are in the actual player controller, because I want to have players playing on one keyboard, right? Therefore, if I actually wanted to really make this scalable, I have to put my controller logic in my base worm, and then every time I inherit from it, I could have many different worms, a fat worm, a slow worm, a jumping high worm, like all sorts of stuff. And if you double click this, you'll see that it's empty. There's nothing here, right? And the same goes for worm number 2. That is also empty. There's nothing here, okay? So that's a scalable situation if of course I have my controls on the character. What I'm doing here is not very well scalable, because I don't know how it's going to behave if I decide to add 20 balls, 30 balls, whatever, and maybe I want different behaviors on each ball, so I'm going to have some kind of function to figure out, how the behavior is going to be calculated. But the solution I've arrived to is essentially use the hit component, which is firing off every frame, assuming you don't have frame drops. If your computer starts lagging, of course, physics is secondary frame rate is primary. So whenever the delta between the frame rate and the physics drops significantly, physics actually kind of run on a kind of a different tick rate. And you've got, what I do here is basically whenever I hit a ball, I cast it to a ball, get its velocity, set the velocity to something that is very low in order to preserve some semblance of realism when it comes to physics, because of course you need to preserve velocity. There's no such thing as zeroing something out completely. Although probably 20,000 is a little bit overkill, so I may have to play around with this, or maybe even promote this to a variable and just play with that. But I'm setting the velocity to 0, and I'm sending an impulse in the opposite direction of the impact normal, which of course, if this is the object, the impact normal will be pointing towards the object. So this is my ball, and this is my, this is kind of dumb what I'm doing right now, but just imagine that this is the ball, and imagine that this is the player worm. The ball hits the worm, and this impact normal is going to be pointing towards the worm, because that's exactly where it is. So if I send a positive impulse, I need to send a negative, obviously, so that it goes the other way, right? Otherwise, the impulse will be pointing downwards, and nothing's going to happen. Anyway, that aside, this is my solution. This is really all I do. And when it comes to physics, there's one more thing you need to understand. You could go for velocity change, and these ticks, whenever you flip this bit, is basically telling the engine that just don't have mass as part of the calculation, right? So the ball could be heavy, could be like tons and tons of kilograms in weight, but it could also be a gram. And this impulse will simply imply a velocity change. So that's something that you might use later down the line. Another way to add force, you generally don't want to be setting the linear velocity. Like in general, you don't want to be setting the linear velocity in any way. Even if you try to add a velocity, you should probably add force. And the add force is, of course, its own node. The caveat with the add force is that this node has to be ran on event tick, or on some kind of, okay, this is not, okay, it's over there. But it has to run on some kind of tick, right? It could be a timeline, it could be a timer, it could be anything that executes over time, but it cannot be like an impulse where you just say, just snap your fingers and it just flies off. This is a constant, it's kind of like a thruster. In fact, the tooltip, I believe, yes. So the tooltip for most of these is very helpful. You should most of the time read the tooltips. They're very helpful. Especially when it comes to, okay, what is velocity change? Well, if true, the strength is taken as a change in velocity instead of an impulse. In other words, mass will have no effect. Oh, great, cool. What does this do? Oh, this bit will, add the velocity to the current velocity. So that's what you could use as well. Instead of just getting the velocity, multiplying it, or adding it, and then doing it, you could just set a new velocity and add it to the current instead of just doing whatever. So that's something you could do. And another important thing to note is that while you can move objects without applying force to them, so let's say I had the ball and I wanted to add torque, which, by the way, I believe is in newtons per meter, Newton meters. No, sorry. I had a problem like this once. Was it Newton meters or Newton centimeters? I think it's Newton centimeters. So yeah, torque is probably Newton centimeters. So generally speaking, you need pretty high numbers. Also, yeah, the force is obviously in newtons, and as you can tell, a newton is not that huge of a number. So you might have to add a couple of orders of magnitude here, like a bunch of zeros, just to get the correct thing. Not to mention that, of course, I'm dividing this by 2,000 because, again, it's a kinematic object, and the actual velocity of the object on impact is quite high. And I want to reduce that just to have like a brand new hit. Anyway, ignore this for a second. One more thing to note is whenever you decide to move a physics object, you want, let's say you make an actor offset. Offset. So let's say you want to add actor world offset. That means you just want to move it, or you want to set its transform. Maybe something like this, or location. Let's say I want to change its location. As you can see, it's got these teleport bits on it. The reason it has them is because you could execute this on an object running physics. However, physics kind of, they don't support teleportation. You have to turn them off, and that's what teleport does. So if I go ahead and move this over here, for the physics, whenever this thing appears over here, it actually has to run calculations for the entire path traveled. That's not something that you want, because if you have an antenna or like anything that's physics related, it's going to run all the calculations, and as far as it's concerned, it just moved at a credible distance over one frame, or basically no time at all. So it has to compensate and just calculate this entire movement in one frame. Like it's basically, it breaks. All right, it looks ugly and looks like crap, and it jitters a lot. So what you want to do is enable the teleport if you're going to be using the brute force method, which is basically defining your own logic from startup, right? So you say, okay, my ball is going to be having this kind of behavior, so I will say, well, like let's say you want to really brute force it and just ignore the physics engine entirely. Then you'll be using your own functions and how you're going to do the air drag and how you're going to do that, and going to have like some kind of a timeline or something that reduces the acceleration or the rate of change of position in the world. Maybe you do something like this, or you use any of these and you just completely redo your controller and remove the floating pawn movement, if you're using it, of course, or remove your own code for moving the pawn and add a sphere or something, and then just use the sphere to drive the position of the player by adding torque to it, or using actor offsets. I don't know, like there's loads of ways, right? The important thing to note is the following. Whenever you have physics and you're doing some sort of teleportation or moving it without applying a force, always teleport. Easy as that. Unless, of course, it's the desired behavior, where you want stuff to be like exploding. I don't know. The further away you teleport, you'll see what I mean. So that's about it when it comes to physics. That's what the add force is. That's add torque. Or you also have other things such as add radial force, which is for explosions, or add radial impulse, and then add radial force, which is for something like a black hole or a vacuum. I have no idea what you would use it for. Loads of uses for this stuff. Nominally, though, you do want to be fairly certain of what you want to do. So that's my approach. Okay, it could be, it's probably, hopefully, going to be different from yours, because I really do hope that you're not copying this game. But it's probably going to be much more different than mine. The point is that your approach should be falling into one of these two categories, right? You either cheat or brute force, or you do it correctly. So 3 categories, right? So again, with the wall example, doing it right is like running around the wall and building the house behind it. Cheating would be using the wall as part of the house, and brute forcing it would be to just destroy the wall and build a house there. Something like this, I suppose. Ideally, though, you do want to cheat at the end of, like, for these small things that are not going to be impacting your game, because the problem with cheating, again, is that they easily break. I mean, you could have something really elegant, and then it's not a cheat; it's just a brilliant solution. But usually, you do something like a cheat, and as long as it sort of works, you're happy with it. And if you don't plan on building upon it, you could just leave it as it is, because as long as it works, it's fine. The moment you start building upon it, though, you really should refactor it into something that's more, approachable or usable or just scalable or non-breakable or safe to use by others, etc., etc., etc. Now, this is, of course, not a final solution. Maybe I decide to add something else later down the line. Maybe I don't like the way this behaves and just the hit gets executed every second and the ball gets kind of snapped onto the worm. That's perhaps not what I want, but I do want this behavior where I can kind of slap the ball inwards, assuming the player learns the correct timing for this. And, of course, I have the proper control scheme for that. So there's something to know about this as well. Now, again, on the other side of the equation, I could use another situation where I decide to use a overlap and say, right, so every time I overlap with something that is a ball, I'm going to send the impulse on it, and it's only going to happen once. So there's no need to do any gates. So you'd have to do onces and gates and be resetting this on the delay that you were kind of setting this, or maybe have a function by timer, or timer event by timer, or whatever you want to call this, so that you can control how the hit is going to behave. However, fact of the matter is, as far as I'm aware, there is no way, unless you download a guy's fork for Unreal Engine 4, who basically exposed a bunch of shit from the physics engine, which, by the way, I don't know if it's going to be still relevant by the time you're watching this, so that's one more thing. The guy's called Olento anyway, so search Olento Physics UE4 and you'll find it on Google, most likely, if it still exists. That being said, though, you could use, as far as I'm aware, no way to replace or at least override the effect of a hit. So it's going to be happening every frame. So if you have collision, you're going to have to disable the collision for however long you want in order to simulate a tick. So that's kind of like a cheat situation. Really depends on what you want to do, right? Depends entirely on what you want to do. And really that's basically it, guys. There's not much else to be. Why is this? Okay, I should have opened the viewport actually instead of the event graph, but whatever. Now, polishing wise, this is of course not polished. It looks like crap. If you wanted to see polish, like something that is recently polished, I suppose would be, I don't know, options menu, although those are not done as well. Kind of stupid polishing stuff early before you finish it, but this would be a polished blueprint, right? Not a lot of code, but you know, a decent chunk of scripting, and there's a bunch of functions here. You could probably should organize these into categories, but it's easily readable, right? There's comments everywhere, and it's easy to understand what the hell is going on. So you can't actually complain for this, right? This is sort of something that you should be going towards. Again, it's not fully polished because there's bullshit like this, but this is an approach that I decided just to try, and it's been crap. Again, you don't want to be doing this. That's just dumb as hell. But for the sake of shits and giggles, might as well leave it in. At least I'm curious how far this is going to last, especially once we start adding the gamepad, because I think this will break. Like, this is not going to work properly because the bind key function is a mess, and it's just checking some crazy crap like names and shit, like instead of checking for array lengths, etc. I mean, I kind of went off-road on this one, right? So I might have to redo it. I have no idea. On your end though, this shouldn't be a real problem. And yeah, I'm kind of trying to think of something that I've missed because, again, this is a very wide topic and there's a lot of problems that could come up with this. And there's a lot of situations where really there isn't even an answer on Google. You kind of have to come up with your own. And that's generally the best. That's when it's generally the best idea to cheat. Yeah. Just make sure to have your physics sorted. Again, in this polishing pass, there's still no need to go super deep. I mean, I said in my own, for example, in this particular project, I didn't even touch up on these curves. They're still default curves. So that's something. But there's a bunch of stuff that needs to be changed. That's probably going to be done in the second polishing iteration. I just want to have some extra functionality. Like in this case, I've added some some sound, extra volume sliders. Probably should add the VSync. Finally, add the VSync and maybe something else as well. But at the end of the day, now you want to have really the capability of just changing numbers, right? So once you're done with that, we'll talk about gamepad and then multiplayer. Hopefully, I don't know if we're gonna do gamepad polish and then multiplayer polish, but I think gamepad multiplayer and then final polish is fine for such a small game. Again, these things, of course, are they're huge. So even though I'm saying it like it's nothing, there's really quite a lot of stuff to go and talk about. Therefore, try to do it as functional as possible, but don't adjust numbers just yet. At least I think it's better you do that later down the line. Because if you go ahead and adjust the numbers right, okay, this is not right, I'm going to escape and do something else. And obviously you could use a simulation. So by the way, it's Alt-S. But you could simulate, and whatever changes you make during the simulation, they will stick. You have the option to say, like if I simulate this and then I do something to this object, and if I click it and I say, okay, I want to keep simulation changes, or just press K. I didn't even know there was a thing here. So you say you want to keep the simulation changes, and that will kind of be applied on, once you exit the game loop. So yeah, you could do that, or you could create a cheat UI or some kind of UI just with a bunch of sliders or some settings where you could just try and do this in real time or while you're simulating. So you play and you possess and then you just I don't know, put on your thing and just change a couple of settings and continue playing, right? So that's something you could do as well. Right. So this is like the lowdown for the physics engine. I mean, this wasn't really the best explanation of the physics engine, but I don't think you need that in depth, unless of course you're doing some kind of simulation like pool. If you're making pool, I think if you're making pool, this would be a valid. In fact, pool is probably one of the easier things to make, like like billiards or snooker or whatever. Because really all you need is a board and a stick and just an impulse. Like, actually, now that I think about it, I should have used pool for this example. But on the other hand, I most likely would have lost quite a few opportunities to talk about a bunch of stuff because it would be just balls. Wouldn't need to create a worm, wouldn't need to animate it, all that. So there's that as well. Okay, guys. So I'll see you guys next time whenever we talk about the gamepads, right? Because there's a bunch of stuff there as well. So make sure to get your game sorted at least to a point where you just need to change a bunch of numbers, right? So I'll see you later. Bye-bye.